Okay, let's continue our discussion on interval estimation for the difference between two means. Right, so let's take a look at this this graph. Okay, as we can see, we already discussed the independent cases where the sigma or sigma square is known and sigma or sigma square is unknown for equal variances assumed cases. Alright, so how do we know whether the sigma or sigma square are known? Okay, this is actually based on information given to us, whether the population standard deviation or variance is given or not in the information. Okay, so that's the first stage, and the next stage is you need to determine, okay, whether the variances is equal or unequal. Okay, so for these cases we can only assume, and most of the time the question will give us the assumption, okay, whether the variance is equal or unequal, but we can actually test this assumption by using Levin test. Okay, and this Levin test we will cover in different recording, and we already discussed this one, and for this video I will discuss where this is the case for independent samples, in this independent samples, and the sigma or sigma square is unknown, where we assume that the equal variances or the standard deviation for the first and the second group is unequal. Okay, these symbols here means unequal. So this is equal. Okay, and based on this, as you can see, we will have different formulation for the cases under equal variances assumed and unequal variances assumed. Okay, and we already covered this formula, so let's take a look at examples. Okay, so for this particular example, we will discuss on confidence interval for difference between two means, independent samples, okay, sigma square or sigma is unknown, and unequal variances or standard deviation. Okay, standard deviation and variances is interchangeable, right? And the assumption for the first point and the second point, this is the same, but the third point we can see that there are difference in the assumption for these cases and our last discussion, where for this particular case the population variances for the first group means that first group variances, the second group variances unknown. Okay, but the variances are assumed to be unequal, and what we try to calculate again is actually this one, the difference between two means. So we try to calculate the interval estimation for mu1 minus mu2, and for alpha value the concept is still the same. We determine the alpha value based on given confidence levels, right? And the most important differences between equal and unequal variances formulation is now you need to calculate the degree of freedom by using this formula. Okay, and this degree of freedom is actually needed when you try to find the value of T alpha over 2 df in our statistical table, right? So let's take a look at examples to explain more about this. Right, so let's take a look at example 15. We read the question. The breaking strength of 11 bundles of wool fiber, so you have the first group, wool fiber, have a sample mean 436.5 and a sample standard deviation of 11.9. Okay, so this sample mean and sample standard deviation came from the sample. How many samples? Okay, suppose that we put wool fiber as the first group, so your sample is N1 11. Okay, sample mean, the symbol is x bar, so x bar 1 equals to 436.5, and the sample standard deviation. Okay, sample standard deviation, so S1 equals to 11.9. Okay, the breaking strength of another 12 bundles of synthetic fiber. So this is synthetic fiber is the second group. Okay, the second group. So 12 bundle is number of samples. So N2 equals to 12. Have a sample mean X bar 2. Okay, the 2 here is a subscript to represent the second group of the what we trying to calculate. So we have the first group wool fiber, and the second group is synthetic fiber. Okay, and the standard deviation of 3.61, so means that this is sample standard deviation. The symbol is S. Okay, 3.61. Assume the breaking strength of the two populations are normally distributed with unequal variances. So this is the information given to us to highlight which formula that we need to use. Okay, so this is where we write it in a symbols. Okay, 1 not equals to mu2. Okay, with the two populations are normally distributed. Okay, population with unequal variances. So we're talking about the variances of the population. That's why we use symbol sigma. Okay, so the formula here is this one, because it's already mentioned here, the variances for the population for both the first group and the second group are unequal. Okay, so let's take a look at the formulation. Okay, x bar 1 minus x bar 2 plus minus T alpha over 2 df. Okay, and then S1 square over N1 plus S2 square over N2. Right. And the df, okay, and the df is, okay, and the df is equals to S1 square over N1 plus S2 square over N2 square. Okay, S1 square over N1 square divided by N1 minus 1. Okay, and this one is plus plus S2 square over N2 minus 1. Alright, so the subscript of N1 and N2 is actually referring to the information given to us. Okay, if the subscript is 1, so the information is from the first group, and if the subscript is 2, the information is from the second group. Okay, so let's take a look at the information that we can list out based on our question here. So we have wool fiber. So wool fiber is the first group, while synthetic fiber is the second group. Okay, and we list out all the information given to us. Okay, N1 equals to 11. Okay, N1 equals to 11. X bar 1 equals to 436.5. S1 is equals to 11.9. S1 square is 11.9 we square, and we get 141.61. Okay, and then synthetic fiber 2 N2, the second group, N2 is 12, X bar 2 is 452.8, and S2 is 3.61 S2 square equals to 3.61 square, and you will get 13.0321. Okay, and then the question asks us to construct a 95% confident interval. Okay, construct a 95% confident interval. It means that this is the one that we calculate. Okay, so 95%. How do we determine the alpha value? Okay, 100% minus 95%, so we will get 5%. 5% convert to decimal places, we get 0.05. 5%, if we divide into this decimal places, 0.05. So means that our alpha is 0.05. Okay, so that's the question. That's the information given to us in the question. And next, we transfer this information to the formula. Okay, so the formula is this one. Alright. So the first thing first you need to do is calculate the degree of freedom. Okay, so the degree of freedom equals to S1 square. Okay, S1 square 141.61 divided by N1 is 11 plus, okay, 13.0321 divided by 12, and then you square root. Alright, and then we have another level here, 1.61 and 1, okay, square over 11 minus 1 plus 1 over 12 square root 12 minus 1. Okay, the answer is, okay, you calculate this one. Okay, 1.1511 plus 112, okay, square root 193.3265, okay, over 141.91 over 11 square, okay, 165.73 over 10 plus 13.0321 12 square root 1.4 over 11. Okay, you will get okay, you will get 11.95. okay, and then you round down. Okay, so we just take the first, so the F is approximately 11. Alright, so it means that for this particular formulation, for T alpha over 2 here, okay, for T alpha over 2 here, you will find the value for let's see, I copy first. Okay, file, Okay, so uh, this is the formula. Okay, so this is the formula. Okay, and this is the information given to us. Okay, so okay, I put it here lah. Right, so uh, T 0.05 divided by 2, where the degree of freedom rate 11 is equals to, right, try to find out this information in our statistical table. Okay, and so 0.05 divided by 2 is 0.025, and the degree of freedom is 11, so we use this 2.201. Okay, okay, 0.025, 11, 2.201. So in this examples, this is 2.021, and then we transfer all the information given to us to this formula. Okay, 436.5 minus 452.8, okay, plus minus 2.021 times, okay, square root of S1 square is 141.61 over N1 11 plus 13.0321 over 12, and we square root all of this, and the answer that we will get is okay, the decimal places, this one. Alright, and then we solve this lah. Okay, mu1 minus mu2, negative 16.3 minus 7.551, negative 16.3 plus 7.551. Okay, so this is the final answer. Alright. Okay, so make sure that you calculate the degree of freedom correctly. Okay, and if you find out that my degree of freedom is different than you guys, please notify me. I will recalculate this degree of freedom to make sure that my calculation is correct. Okay, and actually for this particular example, the calculation is quite complicated, and a careful careful calculations needed to make sure that we calculate this correctly. Okay, and I think this is my presentation for today. Thank you guys. See you.